we have studied about the hydrogenation of alkenes and we have started halogenation of alkenes. We had seen some examples in the last lecture. Now we will study about its mechanism. So, mechanism of halogenation of alkenes. So, this is through electrophilic addition. Okay. We had seen what is electrophile and this is electrophilic addition. So, let us take this example. Okay. Now, Br2, this can be written like this, two bromine atoms bonded together. So, now in a molecule, one part is delta positive, one part is delta negative. We know that no bond is completely ionic or completely covalent. So, even in a covalent bond, one atom will be delta plus and one will be delta minus. So, alkenes have loosely bonded pi electrons, we know that, pi electrons, right. So, these pi electrons will attack on the delta plus position of the bromine molecule and this bond will break. So, what happens? A intermediate is formed like this. This is called the bromonium ion. In general, if such bond is formed with any halogen, this is called halonium ion. Okay. Now, we have one Br minus in the system. It will attack to this positive species. Now, how it will attack? So, if we write this species in Sawhorse projection, okay. So, let us say bromine is bonded like this and the hydrogen atoms are like this. So, this Br minus will not attack on the side in which the bromine is bonded. It will attack through the opposite side and it will break this bond. So, these hydrogen move upward and we get this. The bromine has attacked below. And in this case, this bond is breaking. So, this bromine stays upwards and the hydrogens are like this. Now, if instead of this, this bromide ion attacks from here, then same thing will happen, just slightly different. So, this will be the product. So, when we were studying about the hydrogenation of alkenes, we had said that hydrogenation is syn addition, but halogenation is anti addition. Okay. Anti addition means from opposite sides. So, in a bromine molecule, these two bromide groups will attack from the opposite directions, that is, in a carbon-carbon bond, the bromine groups will be attached in opposite directions. Okay. So, overall it forms vicinal dibromide, that is vicinal dihalide. Okay. Now, reactivity order. So, Cl2 is more reactive than Br2, which is more reactive than I2. Basically, I2 is very unreactive. Reaction with iodine is very slow. I2 does not show addition reaction under normal conditions. Okay. And about fluorine, addition of fluorine is very vigorous and highly exothermic. So, this is difficult to control. That is why this reaction is very rarely performed. Mostly the addition of chlorine and bromine are performed. Now, this reaction, that is the halogenation of alkenes, form a very important test, that is called the test of unsaturation. Okay. So, we know that alkenes and alkynes, that is the species having double bonds, are unsaturated and alkanes are saturated because they have only single bonds. Now, alkanes cannot undergo addition reactions because addition reaction is primarily due to the presence of pi electrons. Alkanes do not have any pi electrons, but alkenes have pi electrons. That is why alkenes undergo addition and alkanes do not undergo addition. Now, since we had discussed in the physical properties of alkenes that their physical properties are quite similar to that of the alkanes. So, if we have an unknown compound and we do not know, that is, if it is unsaturated or saturated, that is, it contains double bond or it does not contain double bonds, then we can perform a test with bromine. This is called test for unsaturation. You know that in case of halogen molecules, fluorine and chlorine are gaseous, bromine is liquid and iodine is solid at normal conditions. So, bromine is a reddish orange kind of liquid. So, when we add bromine to alkenes, it forms the addition reactions and form vicinal dibromide. So, since the bromine molecule no longer exists in the reaction mixture, so when we add bromine to alkene, its reddish color fades and it becomes colorless gradually. But in case of alkanes, the bromine will not undergo addition reaction. So, the bromine molecules will remain intact and the reddish orange color will still be visible. So, this is the test for unsaturation. With bromine. Okay. So, bromine molecule is reddish orange. Okay, we can say around red. Bromine is red. Okay, so let's say there is ethene. If we add bromine to it, so bromine was red. After adding to ethene, it will form this 1,2-dibromoethane. So, bromine molecule no longer exists. So, this compound is colorless. So, we see a change of the reaction mixture from red to colorless. So, by this we can detect that the compound that is reacting with bromine has some unsaturation, that is it has pi bond, carbon-carbon double bond. Okay. But if we react with ethane with bromine, then addition reaction will not occur. So, the solution was red, now also the solution will remain red. Okay. So, this test will not be shown by alkane. So, by this method we can differentiate between alkanes and alkenes. Okay. Now, the next reaction of alkane is addition of hydrogen halides, that is HX. This is called hydrohalogenation. Okay. So, alkenes in presence of HX gives alkyl halide. So, let us see one example. If we take ethene plus HCl, so it will give one hydrogen and one chlorine. So, CH3, CH2 and Cl. So, this will be the product. If we take butene and react with HCl, so this will be the product. These were easy, but what will happen if we take propene? Propene plus HCl. Now, two possibilities are there. One possibility can be this, and another possibility can be this. So, where will the chlorine go and where will the hydrogen go? Similar thing will happen if we take but1ene, then also similar two products will be formed, right? So, how will we know that where the hydrogen will add and where the chlorine will add? This is governed by a rule called the Markovnikov rule. Markovnikov rule solves the problem that among these two compounds, which one is major. So, Markovnikov rule says negative part of the molecule to be added goes to the carbon having lesser number of hydrogen. Okay. Negative part of the molecule to be added, in this case HX, goes to the carbon having lesser number of hydrogen. So, if this is the alkene and we add HCl, then negative part among H and Cl, hydrogen is positive, chlorine is negative, right. So, the negative part of the molecule will go to the carbon having lesser number of hydrogen. So, this carbon has 1 hydrogen, this carbon has 2 hydrogen. So, the negative part, that is the chlorine, will come to this carbon having 1 hydrogen. So, chlorine, and the hydrogen will then go to the carbon having more hydrogen. So, this. Okay. So, if we take but1ene, then CH2 and here it is CH. So, here hydrogen will go, it will become CH3, CHCl, then CH2, CH3, right. This is the major product, this is the minor product. Again, no product will be formed 100%, one will be major, one will be minor. Now, let us say this is the compound, we add HBr. What will happen? This has 2 hydrogen, this has no hydrogen. So, hydrogen will add here and bromine will add to this carbon. So, what is the mechanism behind this? In the mechanism, there is H and Cl. This is delta plus, this is delta minus. Okay. Now, this gives H plus, so there is H plus. Okay. Now, these pi electrons will take a H plus. So, H will be attached to one carbon and positive charge will develop on the another carbon. So, there are two possibilities. One can be this and one can be this. Now, this carbocation is a secondary carbocation and this one is a primary carbocation. So, for carbocation stability, tertiary greater than secondary greater than primary. So, this carbocation is more stable So, this will be the major, and this one is less stable. So, this is minor. Now, there is Cl minus in the system, it will attack here and we get this as the major product, and here we get this as the minor product. Okay. So, hydrohalogenation of alkenes undergo through a carbocation intermediate and it follows the Markovnikov rule. Okay. So, in the next lecture we will study about more reactions of alkenes. Thank you.